In this example, I'll do a mesh current analysis problem with two meshes. So to get started here, we can see there are two meshes, two loops that don't include one or the other. So we can define two mesh currents. I'll call them I1 and I2. Now we have to write two KVL equations, one for each mesh. Mesh 1 will correlate with I1. So for this, we follow the current I1. I have a negative 4 volt drop. And then there's a voltage drop here. So there's a V1 and then Vx. And then I'm back at the low side of the voltage source, made a full loop, so that's 0. What we're going to do is we're going to use Ohm's law to write these voltages in terms of mesh currents. So I'll push the 4 volts to the other side. V1 is clearly I1 times 3 ohms. And then Vx, well, that's a 5 ohm resistor. Well, in the direction of Vx from plus to minus, we have I1 flowing, but I2 also makes a contribution. Its contribution is from minus to plus, so we can think of minus I2 going that way. So to make it work, we use a minus I2 that also contributes to Vx. Notice that I1 and I2 are not necessarily the currents that flow through the 5 ohm resistor, but a combination of the two currents is actually the thing that flows through that resistor. And consistent with the passive reference convention and I1, it's positive I1 and minus I2 flowing downward through that resistor that help us calculate Vx. Okay, so then for mesh 2, we could start at the positive node of the 8 volt source. So now we have 8 volts dropping as we go clockwise following I2. The next voltage drop we encounter is across the 5 ohm resistor, and what current flows through this as we go clockwise. In the direction of I2, it's the 5 ohm resistor and I2, but I1 goes in the other direction, but it also makes a contribution. So we'll use I2 minus I1. That's the current flowing clockwise in mesh 2 through the 5 ohm resistor. And then finally, we have the 3 ohm, oops, I see that it's volts, that should be ohms. We have the 3 ohm resistor and I2. All that is equal to 0. Notice I skipped the direct step of writing KVL equation. I just did the KVL equation, but I wrote it in terms of the currents. Another thing I'll point out is that if this is Vx, this is minus Vx. So that's consistent with following KVL around the second mesh in the clockwise direction. Now we have two equations, two unknowns, so we can solve it. I'll write it like this in a matrix form. This is how I set this up. So from the mesh 1 equation, we have this row, and mesh 2 gives us the second row. For mesh 1, we have a negative 5 times I2, so that gives us this term. We have an 8 I1 that gives us this term. Similarly, for the second equation, we have 8 I2 gives us this term, and then negative 5 I1 gives us that term. When I solve this, I'll call this a R matrix. We'll call this an I vector and a V vector. So we will use I, R inverse V, and if you do that math, say in MATLAB or something, you get those numbers. And then if we see what happens here, we recognize that I2 is negative 1.28. So it's actually 1.282 going this way. I1 is I1 is negative 2051, so it's actually 0.2051 amps going this way. And then we can sum things up here. If you checked, you could verify for this mesh that if you plug in these values, you could check that 3 times I1, that is 4, or you could check that and just verify that in your calculator or in MATLAB. Or alternately, you could check the other case that this is satisfied. We'll leave that to you as an exercise to check.